Question 17. The time to failure in hours for an electrical component is exponentially distributed with that PDF given, which is an 0.2 exp minus 0.25t, or an exponential function with the lambda value of 0.25. That number in front is always the lambda for an exp function for these probabilities. What is the probability, correct to 3 decimal places, that the component life exceeds 8 hours given that it has already survived for 4 hours? Okay, well there's two ways you can do this. So the probability that t is going to be greater than 8, well, I mean, given that it's already been 4 hours, so I'm not exactly sure how you write that. Given that given the time equals 4 already. I know that that's not the correct notation. Someone please tell me how to do it if you know. It is greater than 8. Given that time equals 4 already, then we need the integral from 4 to 8 of that little f of t. I'm not going to write it out because we're not going to do that one. dt. Why am I not going to do it? Well, sorry. This is the probability that it's going to fail in there, so we actually need 1 minus that, because that's going to tell us there's a probability, 100% probability that it's going to do something. There's this integral gives us the probability that it's going to fail between 4 and 8, because this is the probability density function of failure. So we need 1 minus the integral across the range, so we get all of the failures, the probability of failing at any point in there, and 1 minus that will be the remaining values. So I hope that made sense, but that's not what we're going to do, because that's actually the exact same thing as the reliability function for 4. Why is that? And that's just because we've got an exponential distribution, and that means that the fact that 4 hours have already passed mean absolutely nothing to the next 4 hours. So all we need is the reliability function for the total number of hours that we have left, 8 minus 4, or 4. So all that means is if you go straight back to page 4 of 11 and get equation 45 from your summary sheet for the exam, then that's going to be equal to e to the minus lambda t, and that is e to the lambda 0.25. R is 4, so it's just 4 times negative 0.25, which is equal to 1, so it's e to the minus 1, or 1 over e. And that's going to be equal to, hopefully the correct answer, 0.3768 or 0.367879. So yes, correct. 0.368, and we're done.